talk about function notation. So when we've previously talked about evaluating expressions, we've said something like, okay, this is previously what we've done. When we go to evaluate functions, let me zoom in. Oop, there we go. We've said something like evaluate y equals 2x plus 1 for x equals 5. Right? And then what we would do is we would take 5 and we would plug it in, right? We would do something like this. We would go y equals 2, and then we would plug in 5 for x plus 1, and we'd get y equals 11. Evaluate y equals 2x plus 1 for x equals 5. That's what we've done before. But here's the thing. Y equals 2x plus 1, this represents a function. This is a function right here. And with functions, we actually have a different type of notation that makes it so we can write this very long sentence a lot faster. So let's talk about what that notation looks like. It looks a little bit like this. All right, this right here is what we call function notation. Let me talk about all the different pieces here and make a note that this is function notation. First of all, the way that you would read this out loud, this says f of x is 2x plus 1 or equals. But this part right here, this f parenthesis x end parenthesis, we read it f of x. And the 2x plus 1 part is exactly the part you see over here. It's that the y and the f of x are, they represent the same thing, but they look a little different. The f right here, this f out front, that is the name of the function. So this function's name is f. Oftentimes we'll use f, g, h. K is sometimes a function name, but the most popular names we give functions are going to be f, g, and h. This is the function name. And this x right here tells us what the input variable is. This is the variable that we're going to plug in into the function over here. So up here we said plug in x equals 5. Right? This is telling us right here, x is the thing you're looking at. X is the thing that will change in this expression, which is the input variable. Big note here, this kind of looks like multiplication, right? This kind of looks like f multiplied by x, and I want to make a note here that that is not f multiplied by x. This is notation, and it says the function, whose name is f, takes the input of variable x. It uses x as an input variable, and the function itself is 2x plus 1. Let me pause this recording real quick and scoot everything down a bit so I can write just a tiny bit more. Give me a sec. All right, I gave myself a little bit more room here. So here is how this function notation works. We, instead of saying evaluate y equals 2x plus 1 for x equals 5, would instead say, in function notation, f of 5. This says to plug the number 5 in for x in this function. So f of 5 would be 2 times 5. So I've replaced this x right here. So I'm still looking at the same function, 2x plus 1. I'm replacing the x with this 5. So 2 times 5 plus 1, which is 11. It's that same result as up here, right? We could write this whole thing. Instead, we would write f of x is equal to 2x plus 1. Instead of saying evaluate for x equals 5, we say f of 5. And that is the same statement. So let's do a few examples here. We have this function 7x minus 1. We're going to plug in a few things. So let's start by plugging in -2. So f of -2, that is taking and replacing this x with -2. This is telling us plug in x equals -2. So we have 7 times -2 minus 1. That's from this function up here. That's -14 minus 1, -15. So f of -2 is -15. For f of 0, plugging in 0 for x. So this is 2 times 0 minus 1. It's -1. F of 0 is -1. And I could write it that way. I'm going to be lazy and just write -1. But we could write f of 0 is equal to -1. F of a, when there's a variable in here, this is still just telling us what to plug in, right? This is like a blank spot. It's like a blank spot here. So if I put an a right in here, that means just put an a in where you see an x. Just replace the x with an a. So this would be 7a minus 1. And that would be it. There's no number because our input was a variable. If we have f of x plus 2, we are now plugging in x plus 2 instead of x. So that 7 stays there. I'm going to put parentheses and plug in x plus 2. These parentheses are not optional, by the way. When you're plugging in x plus 2 for x here, the whole thing needs to be multiplied by 7. That's why I'm putting parentheses here, so that the whole thing ends up being multiplied by 7. And then we still have the -1 on the outside. So 7x, this is where x was, -1. And we can simplify this a bit, right? We can distribute, that'll be 7x plus 14 minus 1. And that'll simplify down to 7x plus 13. All right. And then finally, let me pause and pull everything up a little bit so that this last problem's not falling off the page. All right, I'll move things around a little bit. All right, so for this last problem here, we're really asking ourselves the question, are these two things the same? So the big thing here is f of x plus 2 the same thing as f of x plus f of 2? Let's find out. So f of x we already have, right? It says right here, f of x is 7x minus 1. So this part right here, f of x is 7x minus 1. Let's just work on the f of 2 part. So f of 2 is putting in 2 for x, 7 times 2 minus 1. 14 minus 1 is 13. So f of 2 is 13. F of x is 7x minus 1. Let's put those two things together. So instead of f of x, I have 7x plus 1. And instead of f of 2, I have 13. So I have 7x plus 1 plus 13. And that comes out to be 7x plus 14, which is different, right? That is different. This one here was 7x plus 13. So we cannot just distribute the function. We can't do f of x plus 2 and like a distributing thing and say that this is f of x plus f of 2. That is a no. I'm even hesitant to write that down because I'm afraid somebody will write it down as fact, and this is just not true. We cannot distribute the function out over the variables on it in its input. And that's a really common mistake. So that's big point here. These are not the same. These two things are not the same. Cannot distribute. All right, so those are the basics for function notation and evaluating functions. Big idea, when you're plugging in anything to your function, replace with the input variable. So if the input variable is x, we're replacing the x with whatever's on the inside. If you have more than one variable on the inside here, or more than one term on the inside as the input for your function, be sure to put parentheses around it so that it is being multiplied by whatever it gets plugged into. All right, that's the end of this section. I'll see you in another video. Bye.